End behavior and increasing and decreasing functions. Okay? Like I said, it's going to be kind of new for you, but it's not that hard. Okay. Now that's the danger word when the math teacher says it's not that hard, right?
Yeah.
Okay, but I promise, if you can graph these functions, all you're stating is what happens a long ways out. Okay, so we'll start with something pretty straightforward that you know and love, the parent function x squared, right? You know me better than that.
Is your microphone on?
Yeah.
How much did you go back to the computer and set up?
Everything's all on. Being a little more precise there. Okay. If you are in English class and I told you something was increasing, what was another way you would describe increasing? Yeah, okay, getting bigger. Growing. Growing. Get bigger. Anything else? Any other synonyms? No? Okay. So this is a great description of increasing behavior of a function. Okay? So the question would be, and here's what gets people. In math, we always analyze from left to right. Okay. So if I'm going from left to right in that direction, correct? I'm following this line from left to right. Where is that function increasing? Okay, yeah, where is it going up basically? Is it going up here? No, it's coming down, right? Because I'm going this direction, but is it going up there? Yeah, so this function is increasing. You can use that shorthand if you want. On what interval?
Incorporated.
Starts at 0, correct? To what? Yeah. Forever. It doesn't stop increasing, it just keeps going, right?
Would that be like a bracket?
Why would the 0 not have a bracket?
Just after 0.
At 0, is the function going up or down? No, it's actually flat. Calculus. It's what we call a horizontal tangent line. At 0 is where it turns the corner. Okay. It's like kind of like a car. If your car is slowing down, right? Let's say you're going in reverse. Ooh, you're backing up. You stop, and then you go forward, right? At 0 miles per hour when you're stopped, are you moving forward or backward? No. That's what happens at this point. You're not moving. Okay? So there's nothing happening there. There's lots happening there, actually, but we're not talking about that right now. Okay, so we're moving from left to right. That would be increasing, right? Okay. What would another word for decreasing be a synonym? Okay, shrinking. Shrinking, getting smaller. Okay. Go down, I heard. Yeah, you're going down, right? If we're, again, moving left to right, this function is decreasing. here, correct?
Yeah.
On what interval?
-.
Negative infinity to 0. Okay. Yeah. So this is what trips people up. Don't forget that right there.
So how would you write the answer for that?
Just like I did, it's fine. F of x is increasing or decreasing from, you could also write it like this if you want. Right, you remember that notation as well?
Yeah.
I prefer interval notation of this format because it's shorter, but it does look like a coordinate, maybe a XY coordinate sometimes. Okay. You could also write it like this. Right? Got lots of ways. Get comfortable with all of them because you'll see all of them. All right. So that is increasing and decreasing. Use your parent functions just to identify this spot where it changes direction. Okay. And that's about as complicated as it needs to be for you guys right now. Okay. Questions? You can, if you want, use a table of values to determine increasing or decreasing. Okay. So this is option 2. Okay, option 1 obviously is graph, right? Probably, it varies widely, the suggestions, the numbers you use. You can go by tens, you can go by hundreds. Okay, but just gets a wide variation of what's going on there. Okay, and then plug those numbers into your original function. Okay, so negative 20 squared is? Nope. Yeah, negative 20 times negative 20, positive 400. Okay, negative 10? 0. Okay. So, what do you see? Decreasing, right? It's going down, 400, 100, 0, and then we're going back up, we are increasing here. So there's another way to identify what's happening, if you want. 100 and 400. Okay, I think we're good killing that cat.
We killed a cat in physics. Doing a proper problem. That cat definitely died.
Let's just stick with this one for in behavior. Okay. Does this function have an end?
No. 0, 0.
Oh, that's a good question. What's an end?
Yeah.
Where something stops.
Okay, does this function ever stop?
Yes.
Stops at 0, 0.
It doesn't.
Stop.
Oh, it stops here? What do you mean by that?
That's
No? Okay, it doesn't keep going?
Keep going. Never stop.
But you're saying it doesn't go down here.
Keep going.
Is that what you mean? Okay. All right. So end, the word end,
Keep it going.
okay, means look at where the function is going. Okay, look at the arrows. Okay. where is that function going? Up to what?
Infinity.
Yeah, toward the infinite in this direction, correct?
Yes.
Okay, you need to state that mathematically. Right, you can describe it.
Never.
How do you state it mathematically?
It never.
We use the x and the y values. So we would say for this one, as x approaches infinity, so as the x gets really big, what happens to the y value? Approaches infinity as well. Okay, so that arrow we say is the word approaches. Okay. So that's what you say. As x approaches infinity, y approaches infinity. Okay. That means we're going that direction, right? Off in space. So the end behavior here. Okay, which way are we going in the x direction?
Left. Up.
Towards negative infinity. So these are the standard, this statement will always be a part of your analysis, okay? So as x approaches infinity and as x approaches negative infinity, those are your two starting statements every time. Okay, never changes. What happens to the y value here?
Also.
It's still going to infinity, right?
But not positive.
Positive infinity, right? If that's called end behavior, because where does the function go towards the end of it? Okay. Obviously, it never ends, but that's where it's headed.
So,
Okay.
are we gonna, is this for like all the parent functions?
You can do this with every function we
So
analyze.
what does cube do as well as?
Well, then the.
Okay, let's look, are we good there?
Why
Can I move on?
go to negative?
Okay, let's look at another one. You said a cubic?
Yeah.
S.
Let's make it a little bit more interesting. Why? Because you're going to have to do it when it's more interesting on your homework.
Thank you.
Yeah. So I want to prepare you.
It's right there.
All right. Translation, which direction?
The right three.
Right
up,
three.
left
Down
Up one.
one. Thank you for the correction. And what is it shaped like? Right? Okay.
She's like one of those things, David's the wrong way.
No.
It's definitely comic relief when we do teacher lip syncing and airband at winter homecoming. Okay, so we are analyzing. You want to do end behavior first? Is that where that's where the question came from. Again, always the same statement to start. Okay? Yeah, those are always your starting statements. And then you just have to analyze, Brandon. No spit shining the desk, please.
That's the thing.
Where's the y value going as x approaches infinity?
That.
Yeah, yeah, yeah. Same as the other one, right? And then as x approaches negative infinity, what's happening to the y value?
Oh, that's so cool.
You've just analyzed the end behavior of that function.
Different way you make do it.
Okay. I agree. Some people have trouble with it. Okay, so you're looking at the graph, right? This is how I suggest you do it. You can do a table. All right? Nope. We're going positive here, right?
Think of positive, x is approaching negative infinity and y is approaching.
That's because of
Oh, both here.
Going down.
Yeah, x is negative, y is negative, so it's going down to the left.
So the cube.
So like the top left is how you value it, x is a positive, x is a
The amount of times it crosses the x-axis
Yeah.
is the number.
the top left.
Because of the cube.
If you're going to analyze end behavior with a table, you have to use big numbers. Because we're trying to see what's happening way out, right? So these probably still a little bit small, to be honest with you, but we're going to go with it because we don't need to write that many big numbers.
So you said we should probably grab table with this?
Huh?
Would you rather like?
No, I would tell you just use your calculator or your knowledge of parent functions. Use the graph. Okay? But if you need to, the table's available. Okay? So if I use negative 1,000, you get a really big number.
Yes.
Yeah.
What's 1,000 cubed?
That would be one.
A lot more than I can count.
No, it'd be billion, trillion,
It's somewhere in that neighborhood,
billion.
right? Because it's cubed. 3 times 3. And I'm not being precise here. I did not subtract 3 and add 1. Okay. Ish. All right. Now you happy? All right. Good.
Should we write that as an answer?
Okay. If you write that as an answer,
Ish.
that will be a situational decision on my part. Okay. For this,
That's a million.
I would accept.
Or a million. My bad.
This is okay. Probably not the best notation in the world. Approximately equal to would be better. That's the squiggle equals.
Well, wait, wouldn't it be,
Okay, if you do 100, and then if you do negative 10, what's happening to these numbers? Yeah, they're getting smaller and smaller actually, because they're negatives. Right, so they are still getting smaller, but they're just going to negative infinity, right? You can see that very plainly. You're going to get the same thing here with again, proper notation would probably assert that we need to do something like that. Okay. We are going to positive infinity, right? So x is going to positive infinity, y is going to positive. Oh, good score. Same thing here, right? So if you want to use a table, you can. A lot more work, in my opinion, because you know the parent functions. Just use the graph.
Zero, negative infinity, 0 decreases.
That was great.
Okay. So let's talk about that. Where is this function decreasing?
Negative infinity is 0.
As we move from left to right,
It doesn't.
does that ever go down to the right?
No,
No.
it's increasing at all times.
Okay, that function never decreases. Right. So you don't even have to write that. Okay, so don't even put that on your paper. Okay. So increasing.
Would you write increasing from negative infinity to positive infinity?
Easy as that. As we move left to right, this function goes up the whole entire time. Okay.
unless it stops or where it like switches.
And in fact, it does have one, but we just don't worry about it. So, okay. All right, so increasing and decreasing in behavior. Use the graph. If you need to, you can use a table, but it's a lot more work. Okay.
Why don't you change your grades?
No. This is a lot easier.
You change grades, you let grades you would.
I'm pretty sure Brandon had
You broke this at one point.
I did actually. Just dropped it. Any questions? Okay, this is in calculus. I show you the algebra behind calculating these things. Yeah, it's super easy. My Calc AB class is like, calculus is easy. Why do we have to do hard algebra? That's the way it is. This is not due until Thursday. Okay. So you're going to run into some problems that ask you about continuity. I'm going to show you what that is tomorrow. Okay. So just focus on end behavior and increasing and decreasing today, if you start it. And I'm confident you all will because you're all-star students.
Yeah, except for my.
Sure. Okay. You got about 15 minutes, so.